Hi friends, welcome to my YouTube channel. Today we are going to see about beam. Coming to the definition, a beam is a structural element sufficiently long as compared to its lateral dimensions, subjected to loads transverse to its longitudinal axis. See, beam is any structural member that is sufficiently long as compared to its lateral dimensions. When we are considering the lateral dimensions, this is a lateral dimension and this is a longitudinal dimension. Okay, so any structural element or a member that is sufficiently long enough as compared to its lateral dimension, okay, that is called as a beam. Okay, this beam is subjected to transverse loading. The load is transverse to its longitudinal axis. Longitudinal axis of this beam is in this way, and the load is acting in a direction transverse to this longitudinal axis. Okay, the beam will have a longitudinal axis, that is an axis along the length of the beam. So to this axis, the load is acting in a transverse direction. Okay, generally this beam is said to be in a horizontal plane, whereas the loads acting are in a vertical plane. We say that beams are the structural members carrying transverse loading, that is the vertical loading, but we also know that loads sometimes act in an inclined direction, inclined to that of the transverse loads. Let me give you a diagrammatic explanation of this. See, this is the beam that is sufficiently long as compared to its lateral dimensions, which is supported at certain conditions, certain points depending upon the load conditions. See, this is the beam that is subjected to the transverse loading, transverse to the direction of the longitudinal axis. Okay, so here the beam, due to the loads acting, it is deformed into a curved plane. Now let us discuss about types of supports. Depending upon the support conditions, we have types of supports. I will explain you one by one. First, we have roller support. Roller support is a support having only one vertical reaction. That is, it will restrain the action, it will restrain the movement of this support in this particular direction. Let me explain you with this an example. See, let us take this is the beam. We are providing a roller support to this. Okay, so when we have rollers means this beam can move in this direction because of this rollers, and also this can rotate. Okay, so we are just restraining its movement in vertical direction. In vertical direction, we are not allowing that to move, so it can move in the horizontal direction. It can also rotate. The second one is fixed beam. Fixed beam is we are restraining its movement in horizontal direction, vertical direction. We are also restraining it from moving, from rotating. Okay, so we have three reactions for fixed beam. In roller, we are only restraining it in the vertical direction, so we have only one reaction. Okay, next we have pinned joint. Pinned joint is we are restraining it from only the horizontal reaction, vertical reaction. It can rotate. See, this pin joint is same as that of roller one, but in rollers, as we have rollers, it can also move in the horizontal direction. But here we don't have any rollers, it can only rotate. Horizontal and vertical movement is restrained in this case. So we have only two reactions, one in horizontal direction, other is in vertical direction. Next we have simple support. Simple support is we don't have any restrainments, like we have only vertical restrainment. This is due to gravity. Okay, so we have just two members in this direction, it will support it. So these are the types of supports present. Depending upon the support conditions we have just discussed, we are classifying the beams. First one is the cantilever beam. In the cantilever beam, one end is fixed, other end is free. That is, we have reaction only restrainments in the one side, other end is free. So we have one end is fixed, other end is free. Next, we have simply supported beam. Simply supported beam, one end is hinged and other end is on roller support. Okay, one end is hinged and other is on roller. Overhanging beam. Overhanging beam is, it is a normal simple support conditions, but we have overhanging portion of that beam. Okay. So the simple support beam, when it is overhanging just beside or next to the support, we are saying it as overhanging beam. Okay, overhanging beam. Next we have continuous beam. Continuous beam is a beam resting on more than two supports. Okay, more than two supports. If see here we have only two supports, but if the beam is resisting on more than two supports, we are calling it as continuous beam. Next we have fixed beam, that is the beam fixed at both ends. At both ends we have fixed conditions. Now let us discuss about types of loading. Generally loading is, in basic conditions we see only point loads acting. Point loads in central point load, one is the central point load, that is load acting just in the center span, center of this. Okay, this is L, and in the L/2 span we have a load acting. And in second case we have eccentric point load. Eccentric is, it is just beside or next to the central span. See, this is not the center span, this is L/2, it is L/2, but this is at a distance A from the support. Okay, so the rest of the distance B would become, the B is equals to L minus A, the total span minus this A distance. Next we have uniformly distributed load. This is a case where the load is distributing over the whole span, over the entire span the load is uniformly distributed. Okay, this is same as this condition wherein the loads are represented in the point loads, but also like it is over the entire span, it can be represented in both ways. Next we have point movement, that is there is a movement acting at a particular point, that is at a distance A from the support. Next we have triangular distributed load, or UVL we will say, that is it is distributed from 0 to W. Uniformly it is varying from one point to the other support. Next we have trapezoidally distributed load, that is it is having W at one point load and WB at another point load, and it is varying in this way. So we can also represent it like this. We can take the bottom part as UDL and the upper part as again the triangular distributed load. We can also do solve this in this manner. Thank you for watching the video. If you really like the video or the content, please like, share and comment the channel. Please turn the black thumb blue. Please subscribe to my channel. Thank you.